Hey, welcome back, ladies and gentlemen. Today we are going to talk about solving exponential equations if you don't have bases that can be turned into the same thing. In the last video, we talked about if you have something like 3 to the x equals 9 to the 2x, you could change this 9 into a 3 squared, and then you could make the bases the same number. Today, what we're going to look at are equations where you can't do that trick. So we've got to look at some other ways that we can try and solve these. All right, so let's check out how to solve these problems. So here is a list of steps that you can follow that will help you solve those steps. So the very first step is get the number with the variable by itself. What we want is like 7 to the power of whatever it is, 3x equals stuff. We want the base and the exponent with the variable in it isolated. Change it into logarithmic form. So if you have like 7 to the 3x equals 49, then you would rewrite this into log form. So it'd be log base 7 of 49 equals 3x. Then you can use your calculator to simplify the log section, and then you just solve for x using inverse operations. All right, let's go look at some examples just to make sure we understand these steps and we can see how we can apply them. So this first page is pretty straightforward. Most of the exponentials are already isolated, but let's look at A. We have 5 to the power of x minus 3 equals 30. Because the base with the exponent is isolated, we've already got step 1 done, and we can just go ahead and start with step 2, which is rewrite it in logarithmic form. So our log is going to be log base of 5 of 30 equals the exponent, x minus 3. Once we have this, we're going to type the log section into our calculator. So we're going to have the log of 30, log base 5 of 30. Type into our calculator, and our calculator will spit out a decimal. It's going to be 2.11328 equals x minus 3. Then all we do from here is we solve for x using inverse operations, and this should be pretty easy because even though this is a weird looking decimal, adding 3 to both sides is not very hard to do. 2 plus 3 is 5 plus the decimal. So x equals 5.11328. Just a reminder really quickly, for this, in your calculator, if you can't find the log with the base button, you might have to use the change of logs formula. So if you don't have that button that lets you type in your base, the way you would evaluate this would be log of 30 over log of 5. This will give you the same thing. And these logs have the invisible base of 10. That's just what the log buttons is. Fun fact, if you don't have the log button on the face of your calculator, if you do the natural log of 30 over the natural log of 5, this will also give you the same answer. That way you don't have to go searching for stuff. But if you're lucky enough to have the log button that lets you type in the base, use that. It's probably the most straightforward and hardest to mess up. All right, let's look at example B. Let's do this one in green. So again, our base with the exponent is isolated. So our first step is rewrite it in log form. So we're going to have log base 13 of 9 equals the exponent, 2x minus 7. Then we're going to type in the log base 13 of 9. And we're going to get 0.8 8,56635 equals 2x minus 7. Now we're just going to solve for x. So we're going to add 7. The 7's over here cancel. We have 2x equals 7 point that 8,56635. And then we divide both sides by 2. And we get 3.92832 equals x. Okay. So the worst part about this is you're going to have to deal with these really ugly decimals, but it really can't be avoided when you're dealing with logarithms. So sorry, it's just part of life, you know. It's like taxes and getting a job and I don't know, all the other stuff that adults have to do. This is just one more of those adult things where it's not fun, but you just have to do it because, you know, like 500 years ago, people invented jobs, and now I have to work every day and pay taxes. So, you know what it is. Sometimes it'd be like that. It is what it is. All right. Example C. Let's switch back to, let's do purple. All right. Here, our base with our exponent is not isolated. So we need to isolate this first. So we need to get rid of this 3. This 3 is being added and it's positive. So we're going to subtract 3 on both sides as our first step. So these cancel. We have 7 to the x minus 8 power equals 9. And now that the base with the exponent is isolated, we can rewrite this as a logarithm. So we're going to have log base 7 of 9 equals x minus 8. We're going to type our log base 7 of 9 into our calculator. And we get 1.12915 equals x minus 8. And now we're home free. We just add 8 to both sides. And we get x equals 9.12915. That's our answer. So again, the worst part is getting ugly decimals, but that's just part of growing up, kids. All right. Here we can get extraneous solutions. Yeah, it's possible. So we should just check our answers when we are done getting them to make sure that we don't have any extraneous solutions. Or actually, rather, I don't know that this is the right way to say this. These aren't so much extraneous solutions as they are just not possible. So let's go ahead and take a look at this. 3 to what power equals negative 3? Let's just look at the powers of 3 really quick to see why you can't solve this equation. And then we'll see what happens when we try, right? So if we have 3 to the first power, that's 3. Okay, well, we want negative 3. So what about 3, right? We can't do the positive ones. Squared would be 9. 3 cubed would be 27. We're going the wrong direction. We want to go negative. So let's look at 3 to the negative 1 power. That's the same thing as 1 over 3. That's 1/3. That's 0.333 repeating forever, right? If we do 3 to the negative 2, that's 1 over 9, or 1 over 3 squared. That's not going to work either. So we go from positive numbers to positive fractions. There isn't an exponent you can plug in that keeps the value of the base and just changes the sign. That doesn't exist. So if we try and solve this problem, we do log base 3 of negative 3 equals x. If you type this into your calculator, the log base 3 of negative 3, you're going to get, what do you get? It says domain error, or maybe math error. I think it depends on the calculator. My calculator says domain error. Error. What this means is that logs, you can't put negative numbers in. Logarithms don't let you insert a negative number. It's kind of like a square root, right? Square roots don't let you insert negative numbers inside of them either. Same thing with logs. So as soon as you get to the point of taking a log of a negative number, you can stop the problem and say no real solution. I don't think there, maybe there are imaginary solutions, but I don't really think so. All right, let's look at this one. If we're solving this, we need to isolate our base and our exponent. So we're going to subtract 10. 7 minus 10 is negative 3. 2 to the 8x minus 6. Rewrite this as a logarithm. We have log base 2 of negative 3 equals 8x plus 6. As soon as we see that we're taking a log of a negative number, you throw away the question and you say no real solution. You can't do it. You're not allowed to. All right, cool. So there we go. There's our extraneous solutions, quote unquote. They're not really extraneous. They're just not a solution. So let's go do a few more just mixed up examples. And then we'll get you on your way. Cool, just 2 more examples. So here, the only real difference is instead of like having plus 2, we have times 2. This is being multiplied. But you still do the same thing. We still need to isolate the base and the exponent. So to get rid of this times 2, we're going to divide both sides by 2. So these cancel, and we have 7 to the 3x plus 1 power equals 10. Then we rewrite this as a log. So log base 7 of 10 equals 3x plus 1. We use our calculator to, sorry, I'm typing this in as I'm talking, to evaluate log base 7 of 10. Our calculator says 1.18329 equals 3x plus 1. We subtract 1 on both sides. These cancel. 1 minus 1 is 0, so we have 0.18339 equals 3x, and then we divide both sides by 3. And we get that x equals 0.061098. And that's our answer. All right. Over here, we have a times 6 on the outside. We need to isolate the base and the exponent. So we divide both sides by 6. So we have 2 to the x minus 5 power equals 11 over 6. This doesn't simplify, unfortunately. Then that's fine. It's fine. It's fine. Breathe. I know. Mr. Barton, my 3 greatest fears are losing my dog, losing my car, and fraction. It's fine. Kid, chill. Your calculator's going to do it anyway. Rewrite this as a log, just like we did over here. So we have log base 2 of 11 over 6. You're fine. You're fine. Breathe. Equals x minus 5. Type this into your calculator. You don't even have to do it. Don't trick, kid. So we have log of 11 over 6 with the base of 2. And we get 0.874469 equals x minus 5. Then we just add 5 on both sides. Easy peasy lemon squeezy. There you go. That's your answer. Cool. All right. So on your homework, this should be easy for you, I hope. If it's not easy for you, it means you need to ask for help. If you have any questions, please let me know. I can go over problems with you. If you're getting stuck, please let me know. I can help you. If you're not doing your homework, I can't help you. I don't know what to do with you if you're not working. So, I don't know. Ask your mom. Maybe your mom will help you. Maybe your mom will like blackmail you by saying she'll take your phone away or take your dog away and your car away. That'd be funny. What if your mom took your dog? That'd be hilarious. All right. You guys have a good day. Let me know if you need help. I'll see you next time. Don't forget to like and subscribe.